Students Academy. I hope you all are doing well, and this is the fifth video in the series of Spark optimization techniques. We already talked about spill, skew, and shuffle, how it impacts the Spark performance and how you can mitigate those problems or how you can optimize those problems. So if you did not get a chance yet to watch those videos, I highly recommend you to go and watch them. But anyways, let's start our today's video on serialization. So first thing first, what is serialization, right? So let's understand this by a small simulation. So let's say you write some code. Let's say we have an object data which has name, age, and balance. Now what happens in order to make this data persist on disk or make it transfer over the network, every programming system do something called serialization, and it's nothing but converting this object into a byte of streams. So what happens the moment you do the serialization, this object or the code that you have written in any of the programming language gonna be converted into a stream of bytes, 0101 and so on and so forth, which is the language which machine understands, right? And then these byte streams can be stored on memory or disk or can be transferred over the network. So in simple terms, if I have to summarize, serialization is nothing but converting object into byte of streams. So this is like generic definition of serialization, irrespective of the scenario where you are using it, whether you are using it to transfer data over the network or you are using it in Spark or in any other place. So in short, serialization is the process of converting an object into a byte stream so that it can be stored in memory efficiently. Of course, in order to store a data in memory, you have to serialize it. I mean, not you, but the machine has to serialize it and then store in the memory, or write to disk or sent across the network to other nodes. In Spark, serialization happens in many scenarios. Task distribution. So the moment you submit your job and driver sends the task to worker nodes, it is done after serialization. So it's not being sent as if you have written it in the programming language. So during task distribution and then during shuffling data. So whenever you have a shuffle operation, the data is transferred across the nodes, right? And this is being done after serializing the data. Another place where serialization happens in Spark is caching. So when RDDs or data frames are cached, they are cached in a serialized form. They are not cached raw. So basically, we have primarily two kind of serialization techniques in Spark. One is called Java serialization, another one is called Kryo serialization. So on the left side, you can see Java serialization, and this is the default serialization that comes with Spark. So if you don't touch serialization in Spark, Spark gonna do Java serialization for you. It's very simple, but it actually comes with few bottlenecks. So if you can see on left hand side, we have the code like how you would do a Java serialization. On the right hand side, you can see the code how you would do Kryo serialization. So it's actually a property that you can enable in Spark. So Spark gonna start using Kryo serialization rather than doing the Java serialization. The only thing which makes them different is the amount of data that's gonna be generated after serializing the object. So with Java serialization, usually the data is much more. So imagine, let's say you have an object that takes up 1 MB in memory. So as in raw without serialization, it takes 1 MB in memory. After Java serialization, it could balloon to 2 MB or more. So you see, I mean, this object or this data after serialization gonna be 2 MBs of data. Right now you must be wondering how come this extra 1 MB coming from, right? So this is nothing but metadata that is being added by Java serialization. So this is the Java serialization algorithm which adds some metadata to the data, which makes this data more heavy, you know. But on the other side, if we talk about Kryo serialization, so Kryo serialization does also add some metadata, but it's comparatively less. So the same 1 MB object now serializes to just 1.2 MB. So you see the difference, right? So if you use Java serialization, you might end up using more space. But on the contrary, if you use Kryo serialization, you might be using, or I should say, you must be having less memory to be used after serialization. So this is the key difference. So Java serialization will actually introduce bigger chunk of data as compared to Kryo serialization, which is gonna give you like a small size of data. So this is the key difference between both the serialization techniques. and Java serialization comes as default, and Kryo you have to enable it. So key takeaways. I already talked about these, but let's just revise them. So in terms of performance, Java serialization is slow because it has to add a lot of metadata, which is nothing but making it more heavy. On the other hand, Cryo serialization it's faster. Serialized size, as I already told you before, it's large in Java serialization and it's small in Cryo serialization. I mean, not small than the data because it has to have that data itself in it, but compared to Java serialization, it's way smaller. Ease of use, of course, with Cryo serialization, there is something that you have to do by yourself. It does not come handy, but Java serialization, it's built in, so you don't have to do anything. Cryo does not improve Spark data frame performance significantly with Python. So you should keep this in mind. This is just for the Scala. If you are using Scala with Spark, then only the Cryo serialization gonna help you in a much longer way. If you're using Python or PySpark, it already has something called tungsten binary format, which is already an optimized way of serialization. So if you use PySpark, it uses tungsten binary format, which is actually a very optimized serialization technique. So you would hardly get any changes even if you enable cryo serialization in your PySpark jobs, and especially for the data frames. But if you are working with RDDs, you're not converting your RDDs into data frame, then the cryo serialization might help. But still, I highly recommend if you are using Scala and Spark as a combination for your developments, use cryo serialization. But if you are with Python or PySpark, keep using the default serialization, which is tungsten in this case, and it's gonna be more efficient. So this is a small example that I did to show you the real life difference. So on the left side, you see it's Java serialization, which is taking 6192 milliseconds. And on the right side, if you see, we are using cryo serialization, which is taking just 167 millisecond. Although this data is rough and it's randomly generated just to actually have a big number or the big data set, but you can see the difference, right? With this data, you can see there is a lot of difference. So you can imagine if you work in real life with real life data, it's gonna be a lot of difference. So this is just a practical way. I mean, I just wanted to show you, and you can also have a look on the code to see how I'm doing it. Although it's just a configuration that you have to enable it, and Spark gonna do everything for you. So we talked about what is serialization. We also talked about the different type of serialization that are available in Spark, which is Java and Cryo. We also see how Cryo can be more efficient if we are working with Scala. Now let's also talk about some best practices and optimization techniques that you can keep in mind while working with the Spark and Scala. So first thing, again, use Cryo Serializer, of course. So whenever you are working with Scala and Spark, I highly recommend to use Cryo Serializer. Okay, so do's are of course for faster performance, for low serialized size, and don'ts. Do not use with PySpark data frame. I already actually pressured on this sentence many times, so please don't use it with PySpark. I mean, even if you use it, it will not do any change, and then you would be wondering why I don't have any optimized result after enabling it. So if you are using a Scala and Spark, please do use Cryo Serializer as a first thing if you see there are bottlenecks in your jobs. Second is register custom classes. So when I say use Cryo Serializer, so one way you can do is to enable it in configuration. So this configuration, you just say spark.serializer and then you say org.apache.spark.serializer.cryoserializer. That should be enough. But actually what happens when you go with this kind of implementation, since you did not specify any classes, right? So what Spark gonna do, it's gonna do this something called self-reflection. Self-reflection, it's a concept in Scala where actually Spark identifies classes dynamically and attaches them to be serialized with cryo algorithm. So it could be slow. So that's where this register custom classes comes into picture. So you should actually register the cryo classes. So whatever objects you have, whatever large objects you have, you should explicitly register them as a cryo class. So the Spark has to avoid this slow self-reflection process, and it can also impact the job performance drastically. So if you're using Kryo serialization, you should also register your classes as a Kryo classes, and you can do it with the example that is shown in the screen. Another thing is something called use broadcast variable. So whenever you have large objects, we highly recommend that you should use broadcast variables. Why you should use broadcast variable? Because usually what happens when you have large objects and then you're performing some operations there, so Spark gonna shuffle the data, right? And if you have seen my videos on shuffle, I have clearly shown you how shuffle works in very low level scenario, right? It's gonna serialize the data, put the temporary data on the disk, then it's gonna transfer it over the network, then the receiving end gonna deserialize it and then use it. So it's a lot of work. It's a lot of IO, it's a lot of storage, it's a lot of work. So it's gonna, make your job heavy and it will take a longer time for your job to succeed. So whenever you have large objects, we recommend you to broadcast them. Okay, it's not about the data, it's not about the data frame. Of course you should broadcast the data frame, but data frames actually should be broadcasted when they are small. So we keep a copy of these data frames on every place, but this is broadcasting the variable. So if you have large objects or large classes, so you should broadcast them so they are already available on each worker, and Spark does not do unnecessary movement of data. So to summarize, we discussed what is Java serialization, what is Kryo serialization. Of course, Kryo serialization is 10 times faster and Java serialization is slow and inefficient. Also, I highly emphasize on the saying that you should properly serialize your data in order to reduce memory and shuffle overhead. You can use many techniques that we discussed here, or you can or you can have a close look on your jobs when you have the jobs which are running for longer duration. So this is one of the key concept in Spark, because anything which is moving within the cluster, it's actually moved after serialization. So this is very important concept, and usually people ignore it because they don't see it as a big thing which can actually change the performance of the job. But I highly recommend that you should also fine tune these properties in order to have most out from the Spark jobs. So it was a small video, but please do let me know what serialization challenges have you faced in Spark, or you never even bothered to see them. So I actually am looking to know the challenges that you might have faced in serialization, and if you have faced some challenges or if you like this video interesting, please comment below. So this was all about serializations. It was not a big big video, but I think it was helpful. I was just trying to explain you how serialization can impact performance if not given a thought. I personally have worked with a dataset where I had to get into this configuration to avoid the long running pipeline, and it was just magical. I mean, because this configuration is actually kind of hidden because no one actually thinks a lot on serialization, but when you fix it or when you try to play around with this configuration, it really works, and then you see the results, and it's really fascinating. So I hope you like the video, and if you do like the video, please like, share and subscribe, and until then, see you in the next video. Bye bye.